Hello everyone, welcome to this video about independent samples t-test. At the end of this video, you can identify the data assumptions for independent samples t-test, run the independent samples t-test using SPSS, and interpret the result of the test. The independent samples t-test or independent t-test compares the means between two unrelated groups and the same continuous dependent variable. For example, you could use an independent t-test to determine or to understand whether first-year graduate salaries differed based on gender. In this study, our dependent variable would be first-year graduate salaries, and your independent variable would be gender, which has two groups, the male and the female. Before using the independent samples t-test, the dataset should actually satisfy the following assumptions. First, the dependent variable should be measured on a continuous scale, that is, interval or ratio. Examples are revision time, measured in hours, intelligence, measured using IQ score, exam performance, measured from 0 to 100, and weight, measured in kilograms. The second assumption is independent variable should consist of two categorical independent groups, two groups. So like for example, gender, there are two groups, male or female. Employment status, employed or unemployed, and smoker, whether he is a smoker or not. The third assumption is there should be independence of observations, which means that there is no relationship between the observations in each group or between the groups themselves. There must be different participants in each group, with no participant being in more than one group. The fourth assumption is there should be no significant outliers. Outliers are simply single data points within your data that do not follow the usual pattern. For example, in a study of 100 students' IQ scores, where the mean score was 108, with only a small variation between students, one student had a score of 156, which is very unusual, and may even put her in the top 1% of IQ scores globally, so that 156 is an example of an outlier. Assumption 5. The dependent variable should be approximately normally distributed for each group of the independent variable. And to test the normality of the dataset, we can use Shapiro-Wilk test of normality. The next assumption is there should be homogeneity of variances. And this can be actually tested using another test in SPSS, the Levin's test. We assume that all those assumptions are actually satisfied by our given data set later on that we're going to use in our statistical analysis using particularly the independent samples t-test. So maybe start with a sample research problem here for our independent samples t-test. A research firm wants to investigate if the number of active cases of COVID-19 differs between a city under General Community Quarantine or GCQ and a city under Enhanced Community Quarantine or ECQ for 15 weeks. So here are the hypotheses. For our null hypothesis or H sub O, The mean number of COVID-19 active cases do not differ between the city under general community quarantine and the city under enhanced community quarantine. For our alternative hypothesis, H sub A, the mean number of COVID-19 active cases differs between the city under general community quarantine and the city under enhanced community quarantine. For the corresponding statement of the problem, this may be actually the statement of the problem included in your manuscript or thesis paper, and this is how you state it. Is there a significant difference in the mean number of COVID-19 active cases between the city under general community quarantine and the city under enhanced community quarantine? For our null and alternative hypothesis, we have H sub O. There is no significant difference in the mean number of COVID-19 active cases between the city under general community quarantine and the city under enhanced community quarantine. The alternative hypothesis is there is a significant difference in the mean number of COVID-19 active cases between the city under general community quarantine and the city under enhanced community quarantine. Let's have an example of a data set here. Okay, so let's say we have here coding. The code, we are going to use 1 for GCQ and use 2 for ECQ. So to organize our data in a Microsoft Excel or in SPSS, we need 2 columns here. For the first column, we have quarantine status, and these are for the 15 weeks for the first city under GCQ, and we can actually continue that. Okay, we can actually put here 2 like this one, and these 2 corresponds to the second city, which is actually under ECQ, and the second column will be the number of active cases. So in here, I'm going to actually show you on how to answer our SOP using SPSS. So this is our data in Excel. Okay, so we have the weeks there, the 15 weeks, 1 to 15. Okay, for the city under GCQ, and 1 to 15 weeks. This is the city. 2 actually means the city under ECQ, and this column here is for the number of active cases for 15 weeks. So we need to actually transfer this in our SPSS. So you just click here, you start with 1 here, you have to copy, highlight all of this data here. Okay, and then you right click, you copy, and we go to SPSS. So in SPSS, we have what we call data view and variable view here. We need to actually input our data in the data view. So since we just copied the data in our Microsoft Excel, we need to paste it here. So click on this first cell here, you right click, and then you choose paste. So here is our data. Okay. Now, we're going to change the variable name and some other characteristics of our data using variable view here, below here. Look at this. You click at this part here, and then you can see there's a column for variable name. Then we're going to actually change it. So the first column based from our Microsoft Excel file is actually the quarantine status, isn't it? And the second is actually the number of active cases. Okay, so that's it for the name. And as you can see, if we go back to data view, the variable name here actually changes to what we had just actually inputted: quarantine status and number of active cases. Going back to the variable view, we need to change or determine the measure of the level of measurement of our data. So for the quarantine status, that's actually, it may be ordinal, or you can actually name it as nominal. And for the number of cases, since it's numerical, we need to use a scale. Okay, actually we have 4 levels of measurement. If you still remember, we have nominal, ordinal, interval, and ratio. The scale here actually refers to the numerical level that actually includes the interval and ratio. So since this is a number of active cases, we choose scale. And those measurements which are nominal or ordinal, we need to actually change their values. So we go to this column here, and we need to actually use the coding that we used a while ago for quarantine status. So you click on this part here, and then a dialog box will appear. And then for quarantine status, if you still remember in our coding, the value 1 means GCQ, isn't it? GCQ. And for the variable 2, it's actually the enhanced community quarantine, or ECQ. So you have to put it there and then click add, and then if you're done, click OK. Okay, so actually for the number of active cases, we don't need to actually do some values here because it's a scale. You only do the values when our measure here is nominal or ordinal. Now, so that's it. So we are ready for the data analysis using independent samples t-test. Okay, so that's how to actually input our data in SPSS. If you want to actually see the effect of our values a while ago for the quarantine status here, you can just click view, and then you check the value labels, and you can see here GCQ, ECQ. Okay, and I will uncheck it again so that it will become a number. Now we're ready to answer our SOP, the statement of the problem a while ago. What is there a significant difference in the number of active cases between the CT under ECQ and the CT under GCQ? So we're going to use independent samples t-test. So you need to click analyze here for in the menu bar. So click that part, and then you choose compare means. Okay, so as you can see here, you need to actually use independent samples t-test. So click on that, and a dialog box will appear. So we are going to fill up these boxes here for the test variable and the grouping variable. The test variable is actually our dependent variable, the one that we actually measured, okay? And it's actually the number of active cases. So you click on that, and you click this arrow to actually transfer the variable to this box of test variable. Our grouping variable is actually the quarantine status. So click on quarantine status, and you click this arrow, okay, and it becomes our grouping variable. Okay, after that, you click define groups, and we use the coding for the GCQ. Group 1 is 1, group 2 for ECQ is 2, so we use 2 for ECQ. And you click continue. You may click on options if you want to change this 95% here. If you use 1% level of significance, you may change this to 99, and let's use 5%. So we use here 95%. Okay, for the 5% level of significance. So we click continue, and then you click OK, and there's the output for our independent sample t-test. Okay, so how are we going to organize this data? What are the values that we need to present in our thesis paper or manuscript? So I'll continue it with my PowerPoint presentation here. So we have here the output of the SPSS using the independent samples t-test. So in our manuscript, the table will be like this. There will be a column for the quarantine status, a column for the mean, SD or standard deviation. We have the column for the computed value. We use T here for t-test. We have the probability value P and the decision. Okay, so for the quarantine status, you write GCQ and ECQ, or maybe the city under GCQ and the city under ECQ. For the mean, you have to look at this column here for the mean. You may round off the mean up to 2 decimal places, so you get those values we have here. For the standard deviation, this one, you may actually get up to 3 decimal places. So this is the values for standard deviation. For the computed value, you need to get this t here, the value of t. The first value, or the value above. Do not copy the 2, okay? So just copy 1. There should be only one computed value for t. So that's 4.148, this one above it. And then for the significant, or I mean the p-value, you have to look into this column for sig, two-tailed, and you just copy the value above it, okay? That's 0.000 or 0.000. And then how to make a decision. So to make a decision, isn't it, we actually learned before, okay, that to make a decision, we just compare the p-value with that of our level of significance. So in this study, we use 0.05. So since the p-value is less than 0.05 level of significance, we need to reject HO. Okay, so that's how to organize, or to get the values from the SPSS output and put it in a table which can be actually presented in our manuscript or thesis paper. So how to interpret the table in our manuscript? So we need also to actually write a title for the table. So the title will be Table 1, Significant Difference in the Mean Number of COVID-19 Active Cases between the two cities under GCQ and ECQ. Okay, so using APA format, the interpretation can be like this. This study found that the city under ECQ had statistically significantly lower number of COVID-19 active cases. So you have 286.67 plus minus 73.743 compared to the city under GCQ 399 plus minus the standard deviation. We have 74.999. And then we have t equals 4.148. This is the computed value, and the probability value 0.000. That's in the APA format. Another format, or on how to interpret the results or the table, is as gleaned on table 1, the computed value t is equal to 4.148, and the probability value p is equal to 0.000, which is less than 0.05 level of significance, indicate that there is significant difference in the mean number of COVID-19 active cases between the city under GCQ and the city under ECQ. This implies that the city under ECQ had significantly lower number of active, or number of COVID-19 active cases than the city under GCQ. Okay, and that's it. I hope you learned from this video. This is Roldan Sibangalan, Diyos mabalo. See you in my next video. Thank you. Bye-bye.